Hey guys, this is Mrs. Brown talking about the lessons from February 7th and 8th. You need to write your CER on Vibranium if you were out today. And I just wanted to show you all the resources that I've given you in order to write it. So there's an interactive periodic table if you want to look for patterns, but really here's the important stuff. Um, you'll have your class period slides that you guys created, excuse me, of each of the groups on the periodic table, each of these color-coded groups, which is where you'll be placing vibranium. I'll come back to that here in a second. Also, you have the vibranium video if you want to go back and make sure that you have gotten the properties from that. They should be on page 50 in your binder already. And then you should have already also read the vibranium article and added any properties that you found here to page 50 in your binder. So let's just go ahead and look at this article. I'm not going to show the video to you again, but it does talk about the fact that Black Panther suit can stop bullets, so we know it's very strong. We've talked about that it's a metal. It can absorb the force of blows and explosions and re-emit the energy. It also looks cool. In its pure form, it glows a mysterious purple. So you've got those properties. It says here, vibranium may be fictional, but many of its chemical and physical properties mimic those of real life elements. Like many metals, it is hard, shiny, and able to conduct electricity. And like some radioactive elements, it can emit energy and glow in the dark. Okay, so emitting energy and glowing in the dark are two properties of elements that are radioactive. Now that's not reactive like we looked at in a lab recently. This is radioactive, meaning it's giving off energy. It's unstable, and it glows in the dark. Okay, so you're going to use these properties and any properties that you saw in the video. Again, these should be written down on page 50 in your binder. And then you're going to go through and match where you think vibranium should go on the periodic table. So if I click through here, non-metals, well, we know it's a metal, so it's clearly not going to go in the non-metal section. So let's see, the alkali metals. Well, let's see if this would be a good place for them. So there are metals, but they are soft metals. And as we know, vibranium is really hard. So this is probably not an ideal location for vibranium. And so I want you to click down through here and figure out where vibranium you think would fit the best. Okay. If a group is not a metal, then obviously you're not going to put it there. Okay. So these guys are highly reactive nonmetals. So you would not want to place it in the halogens. When we think of those two rows at the bottom of the periodic table, I just wanted to clarify that those are the inner transition metals, that there are two different groups. And I noted that the lanthanides are the top row and the actinides are the bottom row. So one thing I haven't told you yet is that about 92 of elements are naturally occurring. So that means all the way, so this row of lanthanides right here, these guys are all, I'm moving it, are all naturally occurring up through uranium at 92. And then the rest of the actinides are man-made. And all of the actinides are radioactive. And you'll see that in your slides. Okay, so I just wanted to point that out. A couple of other things I wanted to point out is that are that obviously there's more than one correct answer to which group it can go in. There are some better answers than others. And then there are, of course, some answers that will not work very well, that won't work at all. Um, don't stress if all the properties don't fit. So, for example, if you found like three properties in the alkali metals that worked, but it was only that they're soft, basically, I'm just trying to say they're not all going to fit. Okay, this is a fictional element, as you know. So just find one that has two or three strong properties that you think match and go with that. Okay. Um, so speaking of two or three, if you use two strong properties, then you can get a proficient. And if you use more than two, you can get an exceeding. Okay. So I'm just going to go ahead and talk to you about this. This is the CER. It's already posted. So the article is linked here. Um, and the prompt says, using your understanding about patterns of the periodic table system, write a scientific argument for where vibranium should go on the periodic table system. Okay, so here, what are the two properties of vibranium that will help you identify where vibranium should go on the periodic table system? So this is just the listing of the properties that you're going to use, obviously, that you're going to use to prove where vibranium goes. Okay, so don't just put any properties. If you're not going to use the fact that it glows purple, then don't write that down. Just write down the ones that you're going to use in your reasoning. Okay, so this can just be a list right here. And then I've given you a periodic table link here that you can go to and use this to tell me I'm going to put them in the alkali metals, okay? Or I'm going to put it in the alkaline earth metals, all right? So use this as your description. So your claim is just vibranium should be placed in the blank, all right? Simple as that. So make a claim below for which category vibranium should be placed. And then based on the evidence you provided, right? So based on the first question, explain using periodic patterns why you think vibranium should go in this location. Okay, so here is where you're backing up your why you chose this location. Okay, so you're going to use those properties and explain why, because of those properties, vibranium would fit well in that location. Okay, and this is the cumulative CER. This is what our unit is culminating in. So we need to make sure that if you have any questions, you ask me, and that we do a good and thorough job on this and get it done as soon as possible.